This time on Project Beyond, it's time to put all the pieces together in our effort to connect a tank to flushometer-driven fixtures. While we build our permanent system, we've built a temporary solution to demonstrate our existing plastic tank driving flushometer-type fixtures. As we've designed and produced these parts, the process has helped to validate our concepts and plans for our permanent system. And some of the temporary parts will have permanent uses. But before we forget, if you're watching this video before Sunday night, March 24th, you still have time to enter our contest to guess the permanent, real title of the Project Beyond series. The winner gets early access to the announcement, a shout-out for their channel, and a limited edition, full-color, cast resin model of the Capturing Toilets 3D logo before it's available to the general public this summer. Just comment or email your best guess to us by midnight Sunday night Eastern Time. The earliest entry with the closest guess will win. And now back to the video. Both our temporary and permanent tank systems will be elevated a few inches above their fixtures to allow for our modular slip joint connection between components. The bridge devices carry the load of their respective tanks and concentrate them onto the particular toilet's attachment surface. We ran into an issue trying to exactly match the inside geometry of a traditional fluid-master tank flush valve for our custom insert, so we built a whole new one instead. It has a lower profile design that provides for a higher tank level and more head pressure to counteract the smaller diameter of the fixture spud that it connects to. The flush valve, fill valve replacement cap, related hardware, and bridge are the only items that were natively 3D printed. The other components were originally 3D printed, but then cast in resin for better mechanical strength and durability. To assemble our temporary solution, let's start from the bottom up. We're using a 1982 Kilgore Argus commercial toilet acquired with the help of our team member, BTR Plumbing, and completely restored inside and out. As detailed in previous videos, we resolved the rear surface issues with the Argus with a custom spud gasket and surface leveler. We also created a taller fixture spud since we added height to the rear of the fixture. Our wider than normal friction ring and tightening nut give us better mechanical stability for this soon-to-be attached tank. We place the just over 2-inch tall bridge down onto the rear fixture surface, which auto-aligns it to the spud assembly. A collar is pre-threaded onto the bridge's center support column and is tightened while pushing down on the bridge. The collar makes contact with the top of the spud nut, and the bridge is then locked onto the fixture by tightening the top spud nut against the collar. We'll check for centering and alignment one last time before attaching the tank. Our now retrofitted plastic Impacto tank is pre-assembled with our custom components and is pushed straight down onto the assembled bridge. To prevent bottom surface stress, we push directly on the flush valve itself to ensure its O-ring connection seats into the spud. The tank and bridge align automatically via the tank's existing mounting points, and we secure the two together with 1/4-20 machine screws. While the completed fixture has passed our stress and leak tests, it certainly wouldn't hold up in a public setting. But of course, this is just for experimentation and fun. And speaking of experiments, how are we going to test it out? We need an apples-to-apples comparison, and so we're going to compare the 1982 Kilgore Argus to our 1985 Kilgore Alpha. The Alpha was designed to be a tank-based toilet and is nearly identical to the Argus in terms of internal waterways for its rim jets and siphon jet. For some of the tests of the Alpha, we'll truly level the playing field and use a flow reducer inside the Fluid Master flush valve to match the inlet flow of the Argus. We'll run a number of tests with various initial water levels, along with plane and object-included flush cycle scenarios. And, as some flushometer fixtures are specifically designed with higher pressure and volume in mind, we'll also be testing with our 1980 Kohler Downing commercial toilet. This is the final episode to be titled Project Beyond. Speaking as the founder of the
Capturing Toilets channel, I want to sincerely thank everyone for their patience as we have worked so incredibly hard over the past 4 years to get this series ready for launch. I can absolutely promise that you will not be disappointed.
Our next video will finally reveal the permanent title of this series in a grand and epic fashion. And our next episode will continue our pre-launch videos with the tank to flushometer toilet flush tests. All of that and more coming soon.